Let's talk about binary operations. So, for definition, a function on that G is a binary operation when it takes two elements of G and it puts it into G. So for all A, B, and G, I call this the operation. B goes is in G. Okay. So in a way, it's closed. We grab two elements, basically. Okay. So an example would be addition for the integers. So for all A, B, and the integers, A plus B is in the integers. So you grab two elements and that element is in the integers. Okay. Now is subtraction a binary operation? And it is. You can use the same argument here that it's a integer minus an integer is an integer. How about multiplication? Is that a binary operation? And a integer times an integer is an integer. What about division? Is there an exception? And the exception would be so is division on the integers a binary operation? Well, is there any instance that it's undefined, right? So if we grab an integer and we divide by 0, it's undefined. And it's not the case that it's in C. So it's not a binary operation. That's where it fails. Okay. Now let's go over some properties of binary operations. They can be associative or commutative. So if G is a binary operation, then it's said to be commutative if and associative if And we have the case that under addition, it is commutative. It is commutative. And associative. And I want you to think of Q, the rationals, the reals, and the complex numbers. If they are even a binary, if they're a bit commutative or associative. And think about that. You guys can discuss that. Okay. Now we said that subtraction with integers is a binary operation. Is it associative? Well, one counterexample would be like set them all to 1. Right? Now is subtraction commutative on C. And we have the case, think of 1 and 2. 1 minus 2 is not equal to 2 minus 1. So no. Okay. Now when you think of different subsets like the positives, it's not 0. And it would be like 1, 2, to infinity. And same goes for C. Not 0. And when you think of those two sets with different operations, if they're a binary operation or not, and this will lead us to closure, or even if they're closed. So this leads to our next point, which is closure. So let's say if G is a set, I want to say group, but it's not. It's a set under a binary operation. Maybe I should call it S instead of G. Anyways, if H is a subset of G, it's said to be closed. H is closed if for all A, B, and H, A plus the binary operation is an H. Okay? So it is the case that if G is associative, or commutative for that matter, then if H is closed, then H would be associative or commutative. Okay, I want to say one thing. Some books will use law of composition. And it's just a binary. It's the same as binary operation. But this has a connotation more if you're like multiplying something. That's why it's a composite. But it's basically the same thing. Anyways, I want to talk about units of a binary operation. So anytime you have a unit, it would be like you times that unit times any element of the set, and it's an identity, and it returns that same number. So let's write out definition of a unit of binary operation. So for all A and G, U is a unit when A equals A, which is equivalent to, if it's not commutative, then it'll be this. This also holds. So in our example of the integers, one is a unit for the under multiplication actually. So 1 times any number equals A, and that's equivalent to A times 1. Okay. And it'll be 0 for addition. And I also want you to think of like the other things we talked about, like quotient reals, the matrices, the dot product, vector product. What's the unit for that? So think about that. Okay. Can there be more than one unit? So suppose there is. So suppose there's one unit here, and there's another unit of the set G under this binary equation. Okay, so U G equals U G, and we're assuming that these two are unique. UG2 equals UG2, right? This is equal to this times that. That's supposedly that's the unit of that. So there's a contradiction here. So UG cannot be UG2. Contradiction. So units of the set G binary operation are unique. Okay, so as an exercise, I want you to think of matrices under different operations. So addition, subtraction, division, multiplication, and different matrices like Q, R, complex, even, like I said before, like the set of these sets and the operations. What are they? Are they binary operations? Are they commutative, associative? Also, if Later on, I talk about units. What are the units of them? And also, lastly, for vectors, what are some famous like things you can do? Addition, subtraction, multiplication. I don't know if you can do division on them, but whatever you can do. And also like the dot product. Is that a binary operation? And is it associative? Is it commutative? And same goes for the cross product. Right? So some people like usually say like, "Hey, why is this useful?" Or I guess that's not the question. Like, yes, one of the questions is how is this useful, but in math, how is this? What does this build up on? And the next thing it builds up on are monoids. So, and that's a binary operation, which is a binary operation. That's associative, and that is a unit. And that's in essence the definition of a monoid. And the set G cannot be empty. Forgot about that. And I'm gonna make some more videos about monoids. That's my upcoming video. So make sure to stay tuned for that. And thank you for watching.